You're going to want to stick around for this one. It's a hot tool, fairly well built, and got a lot going on inside. Today, we are tearing down this, the DeWALT 26950 Heatgun. How's it? And welcome back to the Burton Builds Garage. In today's episode, before we get into the teardown, we're going to talk about 3 of DeWALT's Heatguns. Now, I have left links in the description to all 3 of these, and go check out the specs, go read those user reviews. Now, this one specifically is the D26411. It's the 250 volt, 1800 watt version. Now, you do get 120 volt, 1550 watt version. It's the D26950. That is more for the North American market, I think. And the reason I bring that up is because there is actually a newer model. Now, I wonder what DeWALT could have called this. Well, you guessed it, the 26960. We'll just add 10. The only difference between the old one and the newer one is the new one has got an LCD screen on the back and it reads out your temperature digitally. Now, I don't know about you guys, but for me, hot is hot, and if it's not hot enough, then we'll just turn it up. I don't really need to know that it's at 457.223 degrees. But, that said, if it's a very similar or the same price, you might as well pick up the newer version. You also do get a battery version of this heat gun, and while it is a little bit more expensive, it is quite a lot more convenient to use, and it'll only take you 10 minutes to do a 5-minute job. More about that soon. Now, keep this in mind, the battery version of basically any tool is a lot more convenient to use. And think about this, if you're working out on a farm somewhere and you need to melt a pipe, or you're working in the roof where there's not a lot of power points around, a battery version, even in a heat gun that draws a lot of power, can be a lot more convenient. I would definitely recommend probably using the 9 or the 12 amp flex volt batteries with that unit. Now, I don't exactly have one myself, but it's just what I've read on the interweb of things. You can use the 5 amp version, but again, I don't think the guys are getting like super long run times. Now, the reason I said it might take you 10 minutes to do a 5-minute job is because DeWALT says that to get up to maximum operating temperature, it can take up to 340 seconds, which is around about 5 minutes in my books. So yeah, you might be waiting for it to heat up a little while. But other than that, just remember, it's the convenience you're paying for. Chaps, let's get into the teardown. First thing that we need to remove in order to split the clamshell is to remove the front section here. That's just a plastic heat shroud. And the way we do that is we just grab it and we rotate it anti-clockwise. And it is just a little rotation clip style lock. And then this piece can come off. The shroud is made of a PA66 material, G30, which is a nylon material, glass fiber reinforced 30%. And it is a fairly strong and sturdy piece of plastic. I mean, this thing is not just going to break, even if you drop it. So that said, you do need to be careful of these little nibs. Now, these little nibs, there's 1, 2, 3, 4 of them. They hold this piece onto the front of the gun over here, and you can see those little nibs actually clip into the into those little recesses, I suppose that you want to call it. So what you do need to be careful of is if you had to drop this unit, so let's say we had to clip it back on and you had to drop it on that point or that point, it's going to want to try and pull off at an angle, and that might quite easily break these little nibs off. So just keep that in mind when you are using this tool. The next thing that we need to remove before we can split the clamshell are these little plastic feet. Now, these little plastic feet are usually used if you clip them both backwards. That's to provide a sturdy base to stand the heat gun. Now, the way we're going to do this, if you have a look closely here, in this bottom section there's an open recess, and what we've got to do is we've actually got to take this little piece of plastic and pull it off. Now, it's quite a violent maneuver if you not in full control, but you're basically just going to take the plastic and give it a good tug, and there we go, we can see it unclips. And you're going to do this for both sides. Now, this one is a little bit easier. Now we can just take both of our thumbs and we can just pry it off, and there it goes off the end of the table onto the floor. I'll go pick that up later. In order to split the clamshell, we need to remove 9 fasteners around the unit. Now, you'll notice that these are Phillips head fasteners, and that differs from mostly what we see on the other tools, which are Torx head fasteners. So if you don't have a Torx bit, not a worry with this tool. All you need is a Phillips head screwdriver. And there we have it. So you can see that there's 8 sort of shorter screws and there's 1 longer screw. So just bear in mind where you took that longer screw out of. We'll just move those over to the side, and now we can see that all of the fasteners have been removed, and theoretically now the clamshell should just easily split open. And there we go. If we just pry it open a little bit, that's what the heat gun looks like inside. We can see the clamshell is also made of a PA6/G30, so it's a nylon material, glass fiber reinforced 30%. This is common between all of the DeWalt tools, where they're basically all made of similar or the same material, and it's quite good because it's nice and rugged and strong, and you can actually feel that there's not very much flex in this tool. And this is only a heat gun, so quality build right here. And you can see that the mold inside, I reckon, is probably still in a good condition. I mean, the inside molding is very neat and uniform. Next thing to look at is going to be one of these little plastic feet. The feet are made of, as we can see here, a POM material. Now, if I remember correctly, this is a polyoxomethylene. It's basically just a thermoplastic. And the T2, I can't actually remember what that stands for, so maybe you guys can let us know in the comments. But also, these little units, these little pieces, they are really, really stiff and strong. No reinforcing in it, but again, for this little type of foot, I don't think we need any reinforcing. Quite a nice little unit, nice finished off texture to match the rest of the tool. Within the other half of the clamshell is all of the important bits. Starting at the bottom, we can see we've got a nice rubber strain relief, and that is fastened by 2 fasteners, and it looks like we've got a woven fiberglass shielding inside the cable, which is quite nice. That's going to be definitely there for strength. Moving up, we've got the switch and a little circuit board, and then from the switch moving on to the next circuit board. This one is probably going to be controlling the temperature and the speed rating, or the speed control for the motor. And at the back we've got, we know, our plastic temperature control. Then inside this plastic bit, we've got our impeller that is going to generate the airflow that blows out the front of the nozzle, and within this metal section in the front here, we've got our heating element. So something that initially jumps out at me, which is actually quite a nice design. I originally thought that if you drop this off a table, for that matter, or if it falls off a table and it lands on the point here, then this is quite a long lever moving into the fan section, and I thought over time, if you drop it a couple of times, potentially it's going to break off. But this is quite nice. If you see, it's got a little support ring in the front here. Now this is just a loose ring, we'll have a closer look at that later. And then it's also supported at the back here by the impeller section. So if you had to drop it on this corner, you can see that there's really, really good support in the tool. So you're probably going to dent this pretty badly before anything inside here breaks. That's a really nice design feature. Another nice design feature of this tool specifically, now this is probably common to a lot of heat guns, just implemented in a couple of different ways, but the motor, of course, causes this impeller or the fan section here to draw in air from the back. So air is drawn through here, through these little slits, and it's drawn over the control board, over the motor, and then into the tube or the nozzle section. So there's quite a good airflow over the components to keep them nice and cool. So looking at our little strain relief piece of plastic here, let's see if we can get it in focus. There we go. It's also a PA6 glass fiber reinforced 30%. So nylon glass fiber reinforced 30%. The strain relief is a rubber, a polyvinyl chloride, and that is witnessed by the PVC material markings, which we can see over there. This is a flexible PVC and quite a nice little design. I quite like this little ring. I suppose this could be to hang your tool on the edge of your table if you've got a hook. Yeah, fairly simple. Nice thick rubber compared to some of the other tools that I've seen. It's really going to be a really good strain relief for the cable. To lift all of the insides out, we've just got to carefully lift each section. Now each section is housed in the clamshell by little retaining grooves, and it's just as simple as picking it up. We can also pick up this little component out of its little housing and remove the housing, and it's as simple as that. And we can also see our temperature control here at the back that just slides out of the little potentiometer that we've got on the back of the control board. The front steel support plate is fairly easy to remove. We just slide it off the front of the nozzle. Something to keep in mind when you are reassembling this tool, the front support has got a little cutout on one of the edges, and you can see that little cutout will index with this little nib that is inside this retaining groove. So don't make the mistake of trying to put it in whichever orientation you want, and then the clamshells don't really want to mesh back together perfectly. There's probably going to be like a little 2mm gap, and then you're going to want to try and squash it together. No, don't make that mistake. Just rotate this little front support until it falls or indexes correctly, and then you'll see the two halves of the clamshell will seat nicely together. Something else that we need to be aware of is at the back of the unit where the heat control indexes with the back of the clamshell. Now, the way that does that is it's got a small groove similar to that front mounting plate, and that groove is over here on this half and of course on the other half of the clamshell. And something that we do need to keep in mind is this little tab over here. It's a little triangular tab, and that is going to act as a stopper. And if we have a close look on our this is the bit that controls the temperature. If you have a close look over there, we can see there's a little piece of plastic that is standing proud. That little piece of plastic is going to stop against this stopper. So when you are putting it back together, what I would suggest that you do is that you seat this piece inside like that, and you turn it all the way to the cold position so you can see it rotates and then stops against the cold position. If we were to rotate it all the way the other way, we'd get to the stop, and whoops, too far. There's the stop, and now it's in the hot position. So what you can do, as I said, is you can rotate it all the way to the cold position, and remember where that is. I mean, it's pretty simple. The negative is facing the top here, and then we also need to, on the control section, turn that little potentiometer all the way back to the cold position, and then we index this heat control into that potentiometer and then into the clamshell. The smaller PCB is the first one that we saw at the bottom of the tool, and we can see over here that it is the switching PCB denoted by the actual writing on the PCB. There we've got our standard DeFont switch. Now most of the DeWalt products come out with this style of switch, or this brand of switch should I say, and there's a couple of other components just looking like the basic standard components. An interesting note here that I've just seen, we can see the switch, if we have a look here, is rated at 13 amps 125 volts AC or 6.5 amps 250 volts AC, and then on the other side of the switch there's a 10 amp 250 volt with the alternating current logo. Now by my maths, this is an 1800 watt heating element in here, and if we're using it at about 220-230 volts, that means we're drawing about 8 amps of current. So I'm not too sure how this works, but we've got 6.5 amp rating drawing 8 amps of current. Now again, maybe it actually falls within this rating of the switch, 10 amps, but if it's using that rating, we're slightly underrated, and if it's using this rating, we are slightly overrated. So maybe some of you in the comments that have got a little bit more experience in the electrical side of things can actually let all of us know exactly what is happening. Other than that though, the switch is a standard 3-position switch, so we've got the first position being the off position, and then the middle position, or the center position here, being the first speed control for the motor, and then the third position over there, as you can see, it's marked number 2. That is going to be the second speed control setting for the motor. Next up is the circular PCB, and that was behind the motor section. And in the middle, we can see here a variable resistor or a potentiometer, and that is connected to the actual heat control that you turn on the back. So as we rotate this clockwise, then you get a hotter heat or a warmer heat, and as you rotate it anti-clockwise, the heat drops off. Now this, in conjunction with this next component, which is heat sinked over here, it is branded ST, and I don't know if you can really see it there in the camera, but if I read it closely, it's BTA16-600B, and that's just a standard triac, and that's been used to control the heat. It's rated at 600 volts and 16 amps, so you shouldn't have any problems with this unit. Nice to see that they're using quite a cute little aluminium heatsink, and that is screwed straight through or all the way through the heatsink, and they've used some thermal paste, as witnessed by the little bit of white stuff sticking out behind the triac. Next up, we've got the motor, the impeller, and the heating section. Now, to get this assembly apart, there's 2 tabs, and they're 2 clip tabs. One is over here and one is on the other side. Now what you need to do is be very careful when you're trying to take this apart, because there's only 2. If you had to break one of these off, of course this thing is not going to be pulled together. Unlike if there was 3 or 4, you could maybe get away with breaking one tab, but in this case not really. So we're very carefully going to have to stick a screwdriver underneath there, lift the little tab, and then we can split the section. And just like that, being very careful, we can see that it actually splits quite easily. So I only had to really unclip one side, and then it has come apart. Looking at the motor section, we have a small plastic impeller, and what this is going to do is going to draw air in through the center, and it's going to fling it out through these fins, and then the other side of the housing is going to direct it through and out the heat nozzle. So this is, if we look closely, let's see if we can get it into frame there, PA6 glass fiber reinforced 30%, which is that nylon material. And then if we look at the bottom, it says PA66G30, which a PA66 is still a nylon material. It's just a little bit more resistant to heat, although I'm not 100% sure what's happening here. I'm taking a guess. There's a little arrow that is pointing up to the PA6G30, so maybe this section is just a standard PA6. If any of you in the if any of you watching know exactly what is happening there, just let us know in the comments so that we know for the future. Also, if we have a closer look at the outside of the housing, we can see over here that it's also a PA6 glass fiber reinforced 30%, PA66 glass fiber reinforced 30%, and there's a small arrow pointing to the PA6 side. So likely also just the standard nylon material. If you have a very close look inside the little gap over here, we can see that the impeller is just press fit onto the motor's shaft. So to remove this, we'd likely just have to pull really hard. Now I'm not going to do that, just in case I damage something. I still want to use this unit. And we can also see that inside there's 1 screw and 2 screws in the little gap, and that is what hold the motor onto the front section of our fan. Then if we have a look inside the shrouding over here, we can see that this plastic section is joined to our metal section, and that is joined by 4 fasteners, 1, 2, 3, 4. The nozzle is a fairly sturdy steel. It just looks like it's been electroplated, and it looks like it's been formed by a mandrel being pressed inside here and creating this shape with a little bit of a lipped end. But really nice and thick. I don't think this part is ever going to give problems. If we carefully remove the shielding from the heating element, this is likely just a fiberglass based heating wrap that reveals the standard heating element. So it's quite a fairly sturdy design. It's not as flimsy as some of the other heat guns I've taken apart, so great to see that. And we can see here's our little probably temperature control or our temperature pickup that is going to feed back into the control section, so that is where we're getting our temperature control from. Yeah, fairly good. A little bit of a, again, electroplated section on the front there, little piece of metal, but nothing too special to write home about. I'm fairly happy so far with the construction of this unit, and I hope it's going to last many years to come. Something to keep in mind when you are reassembling your unit is to take note of these little cutouts. So there is one over there, and there's actually one over here. Now those little cutouts will align with these two corners. There's one corner over there and one corner over there. So when we push this whole lot together again, we'll see that those little sections should line up. Now, a general principle here when you are reassembling anything, generally anything, that is to say, don't force things if they don't seem to be going together the way or as easily as they came apart. Especially in cases like this, this is not going to be super strong. It's probably going to be a semi-fragile bit of insulation. So let's just take care when putting it back together. Something else to keep in mind when reassembling the unit is you can see these little plastic tabs. They are on the motor's fan section, and they are going to index into the one half of the clamshell. So you're going to have to look just carefully down inside the unit, and I'll see if I can demonstrate this nicely. But you can see those little plastic pins. There's one on the top and one on the bottom. Those have got to line up with the clamshell. If you don't do that, then the unit is not going to go together smoothly. Also, you'll notice in the PC board there is a small cutout. Now you can see that over here. That little cutout is also going to index into the clamshell, and it's going to index onto this small little nib. So also keep that in mind when you are reassembling the unit. So the bit that I was referring to earlier was to align our variable resistor with the temperature control, or the temperature control indication. So what we can do is just make sure that the variable resistor is turned all the way to the coldest setting. So if we turn it clockwise, it goes hotter, and if we turn it anti-clockwise, it goes cooler. So now it's at the cooler setting, but you can actually see that the speed control or that the indicator is 180 degrees out. So what we can do is pull that off, and we'll turn it around, and then we'll stick it back in, just like that. And now we can see that the negative is aligned to the little arrow on the top. And as we increase the heat, so we turn it clockwise, and everything is aligned as it should be. Now what we can do is we can just make sure that our temperature control knob here is seated in the recess in the clamshell. And one last thing to keep in mind just before you close the two clamshell halves is to make sure that this little black and red wire over here, that is tucked in nicely. And also these three wires, the blue, yellow and black, they've got little cutouts or recesses where they fit into. We want to make sure that all of that is nicely in its position, so that when we put the two clamshells together, that the wires don't get pinched. So I'm pretty happy with this thing. I think it's fairly well built. A little bit finicky to get back together because the wires are so short and there's quite a lot packed into this small little shell. But, you know, other than that, I'm pretty happy with it. Maybe you guys have had yours for donkey's years and you've had good and bad experiences and you want to share those with us. Let us know in the comments. Guys, please give it a thumbs up if you liked the video, and just a reminder to subscribe if you haven't subscribed already. Brew, I guess that's it. We'll see you next time. Cheers.